In this tutorial, we're just going to go quickly through how to create very basic shapes in the PuMA GUI. And when I say basic shape, I mean the kind of thing that you would create in order to run a verification exercise or some kind of canonical case in order to test the code or test your solver. So an example would be box, rectangles, cylinders, spheres, this sort of thing, either two-dimensional or three-dimensional. I'll show a simple example of both. So to open the GUI, first thing we're going to do is open the terminal. This is, of course, assuming that the installation has been done. We're going to say conda activate PuMA. And once PuMA is activated, the conda environment, then we can just say PuMA GUI.sh from anywhere, and the PuMA GUI should open. So in order to create one of these basic shapes, you can either use the Generate tab up at the top to make a sphere, cylinder, box, or click on one of the icons on the side. So let's start with the simplest. Let's just start with a box. If you, for example, wanted to make a box that was the entire domain was just solid, you can create a box here of, let's say, domain dimensions 100 by 100 by 100. So our domain is 100 cubed. And if we want the box to also be 100 cubed, we can start the box from 0 and make the box of length 100. We say generate, and we can see now that we've generated just pure white, and white in this case showing means that it has a value of 255. I'll get into that a little bit more in a second. So now let's say instead we wanted to make a box that was just half the domain in length and centered. We would put the starting point at 25. Note that the starting point is not the same thing as the center point. So the starting point is the minimum X, Y, and Z location that it starts, and then the box spreads from that X, Y, and Z location for the given length that you provided. So now we've created a box that is centered here. So by default, anytime you generate a material in PuMA, it's going to be put on a grayscale value somewhere between 0 and 255. Now that may seem a bit arbitrary, and in some ways it is, but this is the minimum and maximum value that can be stored in an 8-bit integer. So 8-bit TIFF images are what is commonly used for microtomography, and that's the most common way that we import and export things out of PuMA. So we've made the generation kind of fall into that 8-bit framework. Of course, you can segment the images as you want to afterwards. But for our box generator, for example, we have 0 in the solid, 0 in the void, and then 255 here in the solid. So if we were now to render this, and you could render this either as 255 to 255 since it's all that, or I'm going to go ahead and put it to 128 just because that works better with the things that we're making later. But this should render the solid domain here. And here you go. You can see the 3D box. I've pointed this out in other tutorials, but there's a VTK bug on Mac when it's installed with Anaconda or Miniconda, where sometimes when you launch the domain, when you launch the visualization, it's unresponsive to your mouse. It doesn't happen all the time, but sometimes this happens. If this happens, all you have to do is shrink the window, open the window back up, and then it works perfectly. So let's say you wanted to, instead of generating this 3D structure, let's say you wanted to generate just a 1D structure, or sorry, two-dimensional structure. So let's say the Z size is now 1. So this means we're creating a 100 by 100, but only one thickness. So this would be a two-dimensional structure then. Now, the box starting point, we have to change to 0 in this direction, and then we'll make the length just 1 in that direction so that it fills the entire single voxel that we have in the Z direction. Now we can see that it looks the same here, except that it's now 2 dimensions, and if we generate the contour render, then now we can see that we just have this 2-dimensional slice here. So let's move on now to some other different types of material generation. Let's start with a sphere. So we can generate a sphere now the inputs are domain dimensions, so let's just use 100 cubed again. The sphere center point, which is, in this case, we'll just center it in the domain 50, 50, 50, and then the sphere radius, which in this case is just 40. So if we generate this now, you can see the sphere here. Now it may not look exactly like a sphere because of how we generate this outer box here. But if you do a contour render with a threshold of 128, then here you can see that we have a sphere structure. You can also do a volume render, which is going to apply this threshold, and then it'll show you the actual voxelized structure. So here it's doing the VTK bug where it's not responding, so just shrink, expand, and now it works fine. So now you can zoom in and you can actually see the voxel structure if you were to just straight threshold it instead of generating a contour. So if you wanted just a circle, for example, you could make it 100 by 100 by 1, and then you can center the sphere at 0, and then give it this radius. And now if you generate the contour, now we have just a spherical, a sphere structure here. This is just a visualization artifact. It's not stored in the domain. If we were to generate a volume render here, then you can see how the domain looks. Okay, moving on to the last material, which is a cylinder shape. So if we click that, and let's make a cylinder in the Z direction. So what we're going to do is we're going to generate a domain of 100 by 100 by 100. Let's have the start point be centered in the XY plane, and then we'll have it start at 0 in the Z plane. The direction vector determines which way the cylinder points. So you can have it if it's 0, 0, 1, for example, and it will automatically normalize this so you don't have to make it a unit vector. If you have it 0, 0, 1, then it's going to point straight up in the Z direction. If you had it, for example, 1, 1, 1, then it would be diagonal with respect to the 3 dimensions. So we're going to go 0, 0, 1, radius of 20, and then length, we'll just go ahead and make it the whole domain size. So we'll make the length of 100. Now you can see that if we create a 3D render, here you go. You can see that the cylinder has been created in the Z direction. All right, that's it for the simple material generation. We're going to include more tutorials for complex things like fibers and spheres and periodic TPMS, which is triply periodic minimal structures as well. We'll do that in the next video. If you have any questions, if you have any problems at all, please reach out. Our emails can be found in the README and in the Read the Docs document that has the documentation for the code.